Welcome to Om Learning Classes.
In continuation with previous lectures, we continue the topic Basic Fundamental about Frequency Modulation. In this lecture, we are going to learn the frequency deviation ratio and the percentage modulation in FM. So, as per previous lecture, we already know the definition of FM, as the FM is the type of angle modulation in which the instantaneous frequency of the carrier signal is proportional to the instantaneous amplitude variation of modulating or baseband signal, and this will be done while keeping the amplitude of the carrier signal constant. We also know that this is our carrier frequency and we have the positive frequency deviation as well as negative frequency deviation. And with that positive and negative frequency deviation, we have F maximum and F minimum. And F maximum minus F minimum, that is equal to 2 delta F, and which is also known as carrier swing. We also know that the basic FM equation is equal to A cos omega ct plus kf integration mt dt. This omega ct plus kf integration mt dt is our instantaneous total phase angle of FM. By taking the derivative of this theta t, we can also find out the instantaneous radian frequency or instantaneous frequency of FM wave. We also know the frequency modulation index, that is MF. It is the ratio of peak frequency deviation to maximum modulating frequency, which is also known as KF maximum value divided by FM, and that is equal to F maximum minus F minimum by 2 FM. While utilizing these basic fundamental, we have the another factor, that is frequency deviation ratio or simply deviation ratio. It is different from modulation index as it also signifies the bandwidth of the modulating signal. So, as per the definition, the frequency deviation ratio is the ratio of peak frequency deviation corresponding to maximum possible amplitude of modulating signal, which is our MP signal, to the maximum frequency component present in the modulating signal, MP. Or it can be also part of the bandwidth of the modulating signal. So, it is the ratio of peak frequency deviation to the maximum modulating frequency, that is equal to delta by FM maximum, and that is also known as KFMT maximum value to the bandwidth of the modulating signal. So, we can say that that frequency deviation plays a same role for evaluating the bandwidth as MF have the role in single tone modulation system. If we assume that D is equal to MF, then the transmission bandwidth of FM can be calculated from Carson's rules. In next lecture, we have the Carson's rule for FM bandwidth. So, we can say that that frequency deviation ratio controls the amount of modulation and plays an important role in FM. So, we have the important note related with deviation ratio, that the deviation ratio is quite significant because for a FM system, the minimum required bandwidth is greatest. I repeat, the minimum required bandwidth is greatest when maximum frequency deviation is obtained with maximum modulating signal frequency. So, we have three things. First thing, the minimum required bandwidth is greatest, is widest. Second point, it is happened when the maximum frequency deviation is obtained with maximum modulating signal frequency. And as per the worst case of FM, modulation index produce the widest frequency spectrum of the output of FM signal. So, to elaborate this important note, we have an example that for commercial FM broadcast station, we have the deviation ratio that is equal to 5, and that deviation ratio is similar to our modulation index. So it shows that whenever a frequency modulation index of 5 occur for a maximum modulating signal frequency, the signal bandwidth occupied is widest. I repeat, a frequency modulation index of 5 occur for a maximum modulating frequency, the signal bandwidth occupied is the widest. All these three factors are there. But that example, that correlation doesn't mean that whenever a frequency modulation index of 5 occur, the widest signal bandwidth also occur at the same time. The widest signal bandwidth occur when both the things are there. The one is modulation index and another one is your maximum modulating signal frequency. And if we have that, then that will give a significant outcome, that is our deviation ratio. So deviation ratio is important part in FM. When we have the consideration of bandwidth of modulating signal, or we want to control the amount of modulation in FM. So we have another parameter, that is percentage modulation in FM. As per the definition of percentage modulation in FM, it is the ratio of actual frequency deviation to the maximum frequency deviation allowed by standard applicable to FM communication system in percentage form. So we can say that the percentage modulation is the ratio of actual frequency deviation to the standard frequency deviation. And we know very well the commercial FM broadcast transmitter have the standardized frequency deviation, that is plus minus 75 kilohertz. And as per this important point related with percentage modulation or frequency deviation, that important note is that the audio quality of FM increases as the frequency deviation increases. I repeat, if we increase the frequency deviation, then the audio quality of FM signal is increased. And that important factor we utilized in FM broadcast station. So these are the important fundamental about frequency deviation ratio and percentage modulation in FM. In the next lecture, we will learn the another topic, that is Carson's rule for FM bandwidth. So thank you very much, one and all. Stay healthy and enjoy smart learning.